In this video, we're going to focus on the unit circle. So in the unit circle, you need to know that this is the first quadrant, this is quadrant 2, quadrant 3, and quadrant 4. Perhaps you heard of the expression, all students take calculus. In quadrant 1, all sine, cosine, tangent functions are positive. So that's the all part in all students take calculus. In quadrant 2, sine is positive. In quadrant 3, tangent is positive. In quadrant 4, cosine is positive. Those are some things to know. Cosine is associated with the x value. Sine is associated with the y value. So this is 0 degrees, 90, 180, 270. This is 30, 45, and 60. And then there's 120, 150. Well, actually, before 150, we have 135, and then 150. After 150, the next angle in degrees is 210, then 225, and 240. After which we have 300, 315, and 330. Now you need to know the angles in radians that correspond to these values. So 30 is the same as pi over 6. 150 is 5 pi over 6. 210 is 7 pi over 6. And 330 is 11 pi over 6. All of these share the same reference angle, which is 30 degrees. Next you have the pi over 4s. So 45 is 1 pi over 4. 135 is 3 pi over 4. 225 is 5 pi over 4. And 315, that's 7 pi over 4. Now 60 is pi over 3, or 1 pi over 3. 120 is double that amount, so that's 2 pi over 3. 240 is 4 pi over 3, and 300 is 5 pi over 3. 90 is pi over 2, 180 is pi, and 270 is 3 pi over 2. 0 and 360 are coterminal angles. 360 is also equal to 2 pi, by the way. So now, what we need to do is go over the values that correspond to these angles. You need to know the xy coordinates. So for 0, the coordinates are 1, 0. 30, its x is going to be root 3 over 2, and y is 1/2. At 45, it's root 2 over 2. And at 60, it's going to be 1/2, comma, root 3 over 2. And at 90, it's 0, comma 1. Now, if you know the values for the first quadrant, it's going to be the same for the other quadrants, but the signs may change. So in quadrant 2, x is negative, but y is positive. So notice that you have 1, 0 on the right side. 180 is going to be negative 1, 0. Now at 30, we have root 3 over 2, comma 1/2. At 150, it's going to be very similar. Only x is going to be negative, so it's going to be negative root 3 over 2, comma positive 1/2. 135 shares the same reference angle as 45. So therefore, they're going to have the same values. So it's going to be negative root 2 over 2, comma root 2 over 2. And 120 and 60, they share the same reference angle, so it's going to be negative 1/2 and positive root 3 over 2. So as you can see, the values on the left is the same as the values on the right. The only difference is the x values are negative. So now, let's look at quadrant 3. We're going to have the same values, but x and y are both negative. So at 210, 150, and 30, they share the same reference angle. So the values is going to be the same, but it's going to be negative root 3 over 2, comma, negative 1/2. 225 is similar to 45, but negative. So negative root 2 over 2, comma, negative root 2 over 2. And 240 is similar to 60, so we're going to have negative 1/2 and negative root 3 over 2. Now, 0, 1, 270 is opposite to 90, so instead of being 0, 1, we're going to have 0, negative 1. Okay, now for the quadrant 4 angles. 330 is similar to 30. They share the same reference angle. But y is negative in quadrant 4, x is positive. So it's going to be positive root 3 over 2, comma, negative 1/2. And 315 is similar to 45, but y is still negative. So it's root 2 over 2, comma, negative root 2 over 2. And 300 has a reference angle of 60, so it's going to be 1/2, comma, negative root 3 over 2. So x and y are positive in quadrant 1. In quadrant 2, x is negative, y is positive. In quadrant 3, x and y are both negative, but in quadrant 4, x is positive, y is negative. So that's a unit circle. But sometimes it may be difficult to memorize the unit circle. So there's another technique that can help you if you need to evaluate a sine, cosine, or tangent function. But before we get into that, let's talk about how to use the unit circle to evaluate sine and cosine. So let's say if we want to figure out what sine of 60 is. Sine is associated with the y value. Sine of 60 is root 3 over 2. Cosine is associated with the x value. Cosine 60 is 1/2. Now, if you want to find tangent 60 is y over x. It's going to be root 3 over 2 divided by 1/2. The 2's are going to cancel. So tan 60 is simply root 3. So here's another example. Let's say if we want to evaluate sine 180. Sine is going to be the y value. Sine 180 is 0. Cosine 180 is the x value. It's negative 1. Tangent 180 is y over x. It's 0 over negative 1, which is 0. Now let's say if we want to evaluate 300. Not 300, but 330. Sine 330 is negative 1/2. It's the y value. Cosine 330, that's positive root 3 over 2. Tangent 330 is negative 1/2 divided by root 3 over 2. It's y over x. The 2's will cancel, so it's going to be negative 1 over root 3. And if you rationalize it, it's going to be negative root 3 over 3. So that's how you can use the unit circle to evaluate sine, cosine, and tangent functions if you haven't memorized. But now, let's talk about how to evaluate trig functions if we don't have the unit circle or if we don't have it memorized. So let's say if we want to evaluate sine of 30 degrees. How can we do so without the help of the unit circle? So you need to know the 30, 60, 90 triangle. And this, I would commit it to memory. It's going to be very helpful. Across the 30 is 1. Across the 60 is root 3. Across the 90, or the hypotenuse, it's 2. Now there's something called SOHCAHTOA. And we're going to focus on the SO part because S stands for sine. Sine of an angle, let's say theta, is equal to the opposite side divided by the hypotenuse side. O stands for opposite, H stands for hypotenuse, A stands for adjacent. So sine theta is opposite divided by hypotenuse. So we're looking for sine 30. opposite to 30 is 1. So 1 is opposite to it, 2 is the hypotenuse, root 3 is adjacent to 30. So sine 30 is opposite, which is 1, divided by the hypotenuse, which is across the box. So that's 2. So sine 30 is a half. And if you go to the unit circle, if you locate 30, and if you look at the y coordinate, it should be 1/2. So now let's say if we wish to evaluate cosine of 30 degrees. So now we need to look at the copart of SOHCAHTOA. So cosine is equal to adjacent divided by hypotenuse. Adjacent is root 3. So it's going to be root 3 divided by the hypotenuse, which is 2. So cosine 30 is root 3 over 2. Now the next thing we're going to look at is tangent of 30. So if we focus on the TOA part, tan 30, it's opposite over adjacent. Opposite is 1, adjacent is root 3, so it's going to be 1 divided by root 3. Now, you don't want to have a radical on the bottom in the denominator of a fraction, so what you want to do is you want to rationalize it. You want to multiply top and bottom by root 3. So 1 times root 3, well, that's just root 3. Root 3 times root 3 is the square root of 9, and the square root of 9 is 3. So tan 30 is root 3 over 3. Now, the next thing you need to be familiar with is the 45, 45, 90 degree triangle. Across the 45 is a 1, and across the 90 degree angle, or the hypotenuse, is root 2. So if you want to evaluate, let's say, sine of 45, sine of 45, you can use any of the 45 angles. It's opposite, which is 1, divided by the hypotenuse of root 2. And you do have to rationalize it. But when you do, you're going to get root 2 over 2. Sine 45, that's what it is, root 2 over 2. Cosine 45 is going to be the same thing. It's going to be adjacent divided by hypotenuse, which is 1 over root 2, which rationalized to root 2 over 2. Now, tangent 45. What do you think tangent 45 is? So tangent is equal to the opposite side over the adjacent side. So opposite is 1 and adjacent is 1, so it's 1 over 1. Tan 45 is simply 1. Well, that's great. But what if we have an angle that's not in quadrant 1? So for example, let's say if we wish to evaluate sine of 120. 120 is not part of the 30, 60, 90 triangle, so how can we do this? Now, there's something called the reference angle, and that's what you want to use in this situation. The reference angle in quadrant 1 is the same as the angle in quadrant 1, so you don't need it if your angle is in quadrant 1. In quadrant 2, the reference angle is 180 minus the angle in quadrant 2. In quadrant 3, the reference angle is the angle minus 180. And in quadrant 4, the reference angle is 360 minus the angle in quadrant 4. So let's draw it. So 120, that's going to be somewhere in quadrant 2. So this angle is 120. Notice that it forms a reference angle of 60 degrees. The reference angle is the angle between the hypotenuse of the triangle and the x-axis. So we could turn this into a triangle if we want. So notice that we get the 30, 60, 90 triangle. So across the 30 we said is a 1, across the 60 is a root 3, and across the 90 is a 2. Now, because the triangle is in quadrant 2, we know x is negative, y is positive, so we're going to put negative 1 here and leave this as positive root 3. The hypotenuse is always going to be positive. So sine of 120 is equal to sine of 60. The only thing you have to worry about is if it's going to be positive or negative. Now, sine, cosine, or tangent of any reference angle, which is always between 0 and 90, is going to be positive because everything is positive in quadrant 1. So sine 60 is positive. Now sine 120. Sine is associated with the y value. So is sine positive or negative in quadrant 2? Notice that in quadrant 2, the y value goes up. So therefore y is positive, which means that sine 120 is positive. So sine is positive in quadrant 2. Remember, all students take calculus. The s part is for quadrant 2. Sine is positive. So sine 120 is equal to positive sine 60. So now using SOHCAHTOA, we can evaluate sine 60. So it's going to be opposite. Opposite to 60 is the positive root 3 divided by the hypotenuse, which is 2. So sine 60, and therefore sine 120, is root 3 over 2. Now it's your turn. Evaluate cosine of 240. So 240 is in quadrant 3. So that's 240 degrees. And this is 180. So keep in mind the reference angle in quadrant 3, it's equal to the quadrant 3 angle minus 180. So it's 240 minus 180, which is 60. So this angle inside the triangle is 60 degrees. So if we turn it to a right triangle, this is going to be 90, and the other angle is 30. So we have the 30, 60, 90 triangle again. Now across the 30, we have a 1. Across the 60 is root 3. Across the 90 is 2. Now 240 is in quadrant 3, so x and y are both negative. So we can see that cosine 240 is associated with cosine 60 because 60 is a reference angle. But cosine is negative in quadrant 3, so let's put a negative sign. So now let's evaluate it. So cosine is adjacent divided by hypotenuse. Adjacent to the 60 is negative 1, and the hypotenuse is 2. So it's going to be negative 1 over 2. Keep in mind, cosine 60 is positive 1 over 2, but we need to add the negative sign. So overall, it should be negative 1 over 2, because cosine 240 is in quadrant 3, and cosine is negative overall in quadrant 3. So that's cosine 240, negative a half, and you can confirm it with the unit circle. So try this one. Tangent of 330. What's tangent of 330? Now, tangent is y over x, or it's also opposite over hypotenuse. But let's draw it. So 330 is going to be somewhere over here. So this entire angle is 330 degrees. Now the reference angle in quadrant 4 is 360 minus the angle in quadrant 4. And the angle is 330, so therefore we have a reference angle of 30 degrees. So now we can turn this into a triangle, the 30, 60, 90 triangle. Across the 30 is 1, across the 60 is root 3, and the hypotenuse is always 2. Now, in quadrant 4, x is positive, but y is negative. As you go to the right, you can see x is positive, but y is going down towards the negative zone. So tangent 330 is going to be a negative value because tangent is negative in quadrants 2 and 4, but tangent is positive in 1 and 3. So it's going to be negative tan 30. So now let's focus on tan 30. Tangent is opposite. Opposite to 30 is negative 1 divided by adjacent. Adjacent or next to 30 is root 3. So it's going to be negative 1 over root 3. Overall, tangent is negative in quadrant 4. Now let's rationalize it. Let's multiply top and bottom by root 3. So therefore, tan 330 is negative root 3 over 3. Try this one, cosine 225. So 225 is in quadrant 3, and sine and cosine are negative in quadrant 3. So notice the difference between 225 and the x-axis. 225 minus 180, that's a 45 difference. So what we have is the 45, 45, 90 triangle. So across the 45s is 1, and across the 90 is root 2. Because this is in quadrant 3, x and y are both negative. So cosine 225 is the same as negative cosine 45. And cosine 225 is going to be adjacent. It doesn't matter which 45 you pick. Let's pick this one. So adjacent, it's negative 1 divided by the hypotenuse root 2. And don't forget to rationalize it. So cosine 225 is negative root 2 divided by 2. So now let's say if you get an angle that is not part of the special triangles, either the 30, 60, 90 triangle or the 45, 45, 90 triangle. So for example, let's say if you needed to evaluate tangent 90, how would you do it? So you can't really draw a triangle for this. You simply need to know that at 90 degrees, the xy coordinate on a unit circle is 0, 1. And tangent is y divided by x. Tangent is sine divided by cosine. So it's sine 90 over cosine 90. Now it turns out that sine 90 is the y coordinate, it's 1. Cosine 90 is 0. Whenever you get a 0 in the denominator of a fraction, it's undefined. So tangent 90 is undefined. If you were to type in tan 90 in your calculator, it's going to tell you what are you doing. You're going to get an error. So tan 90 is undefined. Tan 270 is also undefined. Cotangent of 0 and 180 are undefined as well. So just make sure you're aware of that. You never know, you might see that on the test. Now let's say if you want to evaluate sine of 5 pi over 6. How would you do it? So here we have the angle in radians. And if you're going to use a unit circle, you can simply take the paper and just simply find out what the y coordinate is and get the answer. So keep in mind, you can go to Google Images and type in unit circle and just print it out and memorize it. But if you want to use the 30, 60, 90 triangle, here's what you need to do. Let's convert radians into degrees. In order to do this, you need to multiply the angle in radians by 180 over pi. So notice that the pi's will cancel. So 180 is basically 18 times 10. And 18 is 6 times 3. So we can cancel a 6. So what we have left over is 5 times 3, which is 15, and 15 times 10, that's 150. So therefore, 5 pi over 6 is equal to 150 degrees. So we're looking for sine of 150. So let's draw it. 150 is in quadrant 2, and it's 30 degrees away from 180. So the reference angle is 30. So we can draw the triangle. So we have another 30, 60, 90 triangle. Across the 30 is 1, across the 60 is root 3, across the 90 is 2. Now in quadrant 2, we know that x is negative, but y is positive. So now, sine 150 is associated with sine 30. So let's focus on the 30 degree angle, the reference angle. So sine is opposite over hypotenuse based on SOHCAHTOA. So opposite to the 30 is 1. And the hypotenuse is 2. So therefore, sine of 150, which is the same as sine 5 pi over 6, it's 1/2. And you could check that with the unit circle. So now it's your turn. Try this example. What is cosine of 11 pi over 6? So let's convert radians into degrees. So let's multiply by 180 over pi. So we can cancel the pi's. Now, 18 divided by 6 is 3. So 180 divided by 6 is 30. So what we have is 11 times 30. 11 is 10 plus 1. So let's distribute the 30. 30 times 10 is 300, and 30 times 1 is 30, so this is 330. So what we have here is cosine 330. Now let's go ahead and plot it on a graph. So 330 is in quadrant 4, and this is 360 or 0 degrees. So we have a 30-degree reference angle. So it's a 30, 60, 90 triangle again. Across the 30 is a 1, across the 60 is root 3, across the 90 is 2. In quadrant 4, x is positive, but y is negative. So we need to focus on the 30 because that's a reference angle. So based on SOHCAHTOA, its cosine 330 is going to be adjacent over hypotenuse. Adjacent is root 3, hypotenuse is 2, so it's positive root 3 over 2. So that's the same as cosine 11 pi over 6. Now let's say if you have tangent negative 150. How would you evaluate it? What's tan negative 150? So what you can do is convert the negative angle into a positive angle by looking for the positive coterminal angle. A coterminal angle is simply another number, but it's an angle that lands in the same position. So to find a coterminal angle, simply add 360 to a negative angle. Negative 150 plus 360, that's going to be 210. So negative 150 and 210 are coterminal angles. They occupy the same position on the on the unit circle. So 210 is in quadrant 3. And here's 180. So the reference angle is 30. So we have a 30, 60, 90 triangle. So across the 30 is 1, across the 60 is root 3, across the 90 is 2, and x and y are both negative. So you need to understand this. Positive 210 is 210 degrees going this way. A positive angle rotates counterclockwise in the opposite direction of a clock. Negative 150, you need to go the other way. This is negative 150. Notice that you end in the same location. Negative 150 is a clockwise rotation. It follows the direction of a clock. But these two angles, you can see that if you add negative 150 plus 360, you get the 210. So it looks like a full circle. So now let's evaluate tangent 210. Based on SOHCAHTOA, tangent is opposite over hypotenuse. And the reference angle of 210, we can see it's 30. So opposite is negative 1. I might have said opposite over hypotenuse, but if I did, it's opposite over adjacent. SOHCAHTOA. So I meant to say opposite over adjacent. So opposite is negative 1 divided by adjacent, which is negative root 3. And so the negatives cancel, so it's positive 1 over root 3. And if we rationalize it, it's going to be root 3 over 3. So that's tangent of negative 150. Now let's say if you have secant, let's say 300. How would you evaluate secant 300? You need to know that secant theta is equal to 1 over cosine. And you need to know the other functions. Cosecant theta is 1 over sine theta. And cotangent theta is 1 over tangent, which is also the same as cosine over sine. Keep in mind, tangent is sine over cosine, but cotangent is cosine over sine. So if you want to evaluate secant, you need to evaluate cosine. Secant is 1 over cosine. So what's cosine of 300? So let's draw our picture. 300 is somewhere over here. And so the difference between 300 and the x-axis, which is 360, we can see that we have a reference angle of 60. So across the 30 is 1, across the 60 is root 3, across the hypotenuse is 2. So x is positive in quadrant 1, but y is negative because y is going down in quadrant 4. I meant to say quadrant 4, not quadrant 1. So in quadrant 4, x is positive, but y is negative. So cosine 300 is associated with cosine 60, and cosine is adjacent over hypotenuse based on SOHCAHTOA. So adjacent to 60 is 1, and the hypotenuse is 2. So cosine 300 is going to be positive 1 over 2. So keep in mind, cosine is positive in quadrants 1 and 4 because x is positive on the right side. But cosine is negative in quadrants 2 and 3 because x is negative on the left side. So if cosine 300 is 1/2, secant 300 is reciprocal of cosine, it's going to be 2 over 1. And so that's the answer for that. So now let's try another one. Let's say if we wish to evaluate cosecant of 240. Feel free to pause the video and see if you can figure this one out. See if you can get the answer. Cosecant is 1 over sine, or 1 over sine 240. So let's draw 240. 240 is in quadrant 3. So 240 is over here. It differs from the x-axis 180 by 60. So the reference angle is 60, and this angle here is 30. So across the 30 is 1, across the 60 is root 3, across the 90 is 2. So both x and y are negative in quadrant 3. So if we wish to evaluate sine 240, we need to focus on the reference angle, the 60. Based on SOHCAHTOA, sine is opposite divided by hypotenuse. So therefore sine 240 is negative root 3 divided by 2. So if that's the case for sine 240, then what is cosecant 240 equal to? So it's going to be the reciprocal of this fraction. So we just got to flip that fraction. So it's going to be negative 2 over radical 3. Now, we have a radical on the bottom, so we do need to rationalize it. Let's multiply the top and bottom by root 3. So cosecant 240 is negative 2 root 3 divided by 3. So that's the answer for that. So let's say if you want to evaluate cotangent of 600, how would you do it? So if you get a very large angle, subtract it by 360. Get the coterminal angle. 600 minus 360 is 240. So we're looking for a cotangent of 240. So let's draw the triangle. So 240 is somewhere over here. And it differs by 60 from 180. So we have a 30, 60, 90 triangle. This is negative 1, negative root 3, and 2. So if tangent is opposite over adjacent, and cotangent is a reciprocal of tangent, then cotangent must be adjacent over opposite. So looking at the 60, adjacent to the 60 is negative 1, and opposite to the 60 is negative root 3. So cotan of 240, which is the same as cotan 600, it's 1 over root 3. And if we rationalize it, it's going to be root 3 over 3. So keep in mind, tangent 600 would be root 3 over 1. But cotangent of 600 is 1 over root 3, which is root 3 over 3. It's reciprocal of tangent. So now let's say if we have secant, let's say negative 11 pi over 6. So what would you do? So we have a negative angle and it's in radians, and we have a secant function. So how would you figure out this one? So let's go ahead and convert radians into degrees. Let's not worry about the negative sign right now. So let's multiply by 180 over pi. Now, I believe we did this one already. 180 over 6 is 30. 30 times 11 is 330. So this is negative 330. Now, because it's negative, let's add 360 to it to make it positive. Negative 330 plus 360, that's positive 30, which is a reference angle because it's an acute angle between 0 and 90. So we're looking for secant 30. So whenever you want to evaluate secant, you want to find out cosine because secant is 1 divided by cosine. So here we could just draw a generic 30, 60, 90 triangle because we're looking for cosine 30. Across the 30 is 1, across the 60 is root 3, across the 90 is 2. So cosine is adjacent divided by hypotenuse. So cosine 30 is adjacent, which is root 3 divided by the hypotenuse of 2. Therefore, secant 30 is the reciprocal of cosine 30, so it's 2 over root 3. And if we rationalize it, we're going to get the answer 2 root 3 over 3. And so now you know how to evaluate secant, cosecant, and cotangent functions, as well as sine, cosine, and tangent functions. Now, here's a question for you. Let's say if sine theta is equal to 3 over 5. How can you find the other 5 trig functions, cosine, tangent, secant, cosecant, and cotangent? So if sine is 3 over 5, draw a triangle in quadrant 1. Sine is opposite over hypotenuse, so the opposite is the 3 part, the hypotenuse is 5. This is the 3, 4, 5 triangle. If you use the Pythagorean theorem, you could come up with the same equation. It's a squared plus b squared is equal to c squared. So it's 3 squared plus the missing side squared, which we'll call b squared, and we have the hypotenuse, which is 5. 3 squared is 9, and 5 squared, that's 5 times 5, which is 25. 25 minus 9 is 16, and the square root of 16 is 4. So thus we have the 3, 4, 5 triangle. Once you find the third side of the triangle, you could find the other trig functions. So cosine theta is adjacent divided by hypotenuse. So that's 4 over 5. And tangent theta is opposite over adjacent. So that's 3 over 4. So now that we have that, we can find the others. Cosecant theta is the reciprocal of sine. And if sine theta is 3 over 5, cosecant is 5 over 3. You just flip it. And secant is the reciprocal of cosine, so that's going to be 5 over 4. And cotangent is the reciprocal of tangent. So if tangent is 3 over 4, cotan is 4 over 3. So now let's say if cosine theta is negative 7 over 25. And let's say the angle, let's say theta is less than 180 but greater than 90. What quadrant is the angle in? Between 90 and 180, the quadrant is number 2. So let's draw a triangle in quadrant 2. So here's theta. Now cosine is negative 7 over 25. Based on SOHCAHTOA, we know that cosine is adjacent divided by hypotenuse. So therefore, this is negative 7 and this is 25. Keep in mind, x is negative in quadrant 2. Anytime you go to the left, the x values are negative. So now what's the missing side? You need to know your special triangles. So we went over the 3, 4, 5 triangle. The next one is the 5, 12, 13 triangle. And there's the 8, 15, 17 triangle. And the 7, 24, 25 triangle. So the missing side is 24. There's some other special triangles too. I've seen like the 9, 40, 41. and also there's the 11, 60, 61 triangle. So now that we have cosine, we can find the other stuff. So sine theta is opposite over hypotenuse. Opposite is 24, so it's 24 over 25. Tangent theta is opposite over adjacent. That's 24 over -7. So secant theta is the reciprocal of cosine, so that's going to be -25 over 7. And cosecant theta is the reciprocal of sine, so that's 25 over 24. And finally, cotangent theta is the reciprocal of tangent, so it's -7 over 24. So now it's your turn. Let's say if tangent theta is equal to 8 over 15 and theta is less than 270 degrees but greater than 180. So the first thing you need to find is the quadrant. So clearly this is quadrant 3. So let's draw a triangle in quadrant 3. So here's our box, and here's theta. So this is the 8, 15, 17 triangle. Opposite to theta is the 8. Adjacent is 15. The hypotenuse is 17. In quadrant 3, x and y are negative. So now let's find sine theta. Sine theta is opposite over hypotenuse. Opposite is -8. Adjacent is -15. Hypotenuse is 17. So it's going to be -8 over 17. Cosine theta, that's adjacent over hypotenuse, so -15 over 17. Cotangent theta, the reciprocal of tangent, so that's 15 over 8. And cosecant, that's going to be -17 over 8. And secant, -17 over 15. Now let's say that secant theta is, let's say it's 13 over 5. And let's say that sine theta is less than 0. Go ahead and find the other 5 trig functions. Feel free to pause the video. Now, the first thing we need to do is identify the quadrant. So, if secant is positive, that means cosine is positive because cosine is 1 over secant. And sine is negative. In which quadrant is cosine positive and sine negative? Cosine is associated with x, sine is associated with y. So if x is positive, we need to go to the right. And if sine or y is negative, you need to go down. So therefore, this is in quadrant 4. So theta is over here. Now secant is 13 over 5, which means that cosine is 5 over 13. So the adjacent side is 5, hypotenuse is 13, the missing side must be 12. But notice that y is going down, so it's -12. So now we can find sine theta. That's -12 over 13. And cosecant theta is 1 over sine, so that's going to be -13 over 12. Tangent theta is opposite over adjacent, so that's -12 over 5. And cotan theta is -5 over 12. Now, sometimes you may not have a special triangle to go by. So let's say if sine theta is 2 over 5. And let's say it's in quadrant 1. Go ahead and find the other trig functions. So we're going to follow the same pattern. So opposite is 2 and the hypotenuse is 5. What's the missing side? So if we use the Pythagorean theorem, we could say that A is 2, we're looking for B, and C is 5. So 2 squared is 4, 5 squared is 25. 25 minus 4 is 21. So B squared is equal to 21, which means that B is the square root of 21. So that's the missing side. So now let's find cosine. Cosine theta is going to be adjacent over hypotenuse, so that's root 21 over 5. Tangent theta, that's opposite over adjacent, that's 2 over root 21. And you got to rationalize it, so this is going to be 2 root 21 over 21. Now if you want to find cotangent theta, don't flip this fraction, flip this one, it's easier. So cotangent theta is going to be just root 21 over 2, so you don't have to rationalize it anymore. Secant theta is 1 over cosine, so it's going to be 5 over root 21, and that you do have to rationalize. So that's going to be 5 root 21 over 21. And finally, the other one, cosecant theta, is just 5 over 2. Now let's say if cosine theta is, let's say it's 3 over 5. And let's say the quadrant is 1 again. So we know this is 3, this is 5, the missing side is 4, 3, 4, 5 triangle. But using this, if cosine is 3 over 5, how can you find the double angle sine 2 theta? There's a formula for this. Sine 2 theta is 2 sine theta cosine theta. And we know that sine, based on the triangle, it's opposite over hypotenuse, so it's 4 over 5. And we already have the value for cosine, that's 3 over 5. 2 is the same as 2 over 1. 4 times 3 is 12, times 2 is 24. So it's 24 over 25. That's how you can evaluate the double angle using the triangle. Now, if you want to find cosine 2 theta, we can use the equation cosine squared minus sine squared. Cosine squared, that's 3 over 5 squared. Sine squared, sine is 4 over 5. 3 squared is 9, 5 squared is 25, 4 squared is 16. 9 minus 16 is negative 7. So it's negative 7 over 25. Now, if you want to find tangent 2 theta, you can simply just divide sine 2 theta by cosine 2 theta. So we have the value of sine 2 theta. In the last example, we said it was 24 over 25. And we have the value of cosine 2 theta. It's negative 7 over 25. If you multiply the top fraction by 25 and the bottom by 25, the 25s will cancel. So tangent 2 theta is simply negative 24 over 7. By the way, if you want more examples, I've created another video on, I believe it's entitled Trigonometry, Pre-Calculus, Overview, Review, Tests, something like that. It's somewhere on YouTube. And it covers a lot of examples on trigonometry and questions like what we're dealing with right now. And there's another one, verifying trigonometric identity. You can check out those videos because that topic most students have great difficulty with. So if you ever come to a point where you have to know how to prove one side is equal to the other side, if you have to prove or verify the identity, check out the video. I've created one. Might be of great help to you. So now let's move on to our next topic. So let's say if sine theta is equal to x divided by 3. What is the value of cosine theta? Sometimes you may see a question like this. And if you do, what do you do? I mean, how do you solve it? So let's draw a triangle. And let's assume that it's in quadrant 1 because everything is positive. If there's no negative sign, assume it's in quadrant 1. So here's theta. And now we know that sine is opposite over hypotenuse. So we got to find a missing side. So let's solve for b. We'll call b as the missing side. So a squared plus b squared is equal to c squared, according to the Pythagorean theorem. So a is x. We're looking for b. C squared, that's 3 squared, which is 9. So to isolate b squared, we need to subtract both sides by x squared. So b squared is 9 minus x squared. And to solve for b, we got to take the square root. So b, let me get rid of this b here. So therefore b is the square root of 9 minus x squared. So now we can figure out what cosine is. So cosine is adjacent over hypotenuse. So that's radical 9 minus x squared over 3. And that's how you do it. So if I want to find tangent, it's opposite over adjacent. Opposite to theta is x, adjacent is root 9 minus x squared. So it's going to be x over root 9 minus x squared. And you can easily find the other stuff. Cosecant is the reciprocal of sine, so cosecant is 3 over x. Secant is the reciprocal of cosine. That's 3 over radical 9 minus x squared. And you can rationalize it if you want to. And cotangent, that's going to be radical 9 minus x squared divided by x. Now the last thing that we need to talk about is inverse functions. So for example, sine 30, if you use the unit circle, if you look for the y value, sine 30 is a half. So therefore, the inverse sine of a half is 30. So sine of an angle is equal to a value. 30 degrees is the angle, 1/2 is the value. The inverse sine of a value is the angle. Whenever you're dealing with an inverse function, basically you need to switch the variables. You would switch x and y. In this case, we're switching the angle with the value. But now you have to be careful because the inverse function has limitations, whereas the sine function, its domain goes on forever, from negative infinity to infinity. So here's an example to illustrate that. Sine of 150 is also a half. However, the inverse sine of a half, and this is important, it does not equal 150. Question is, why? Well, as we mentioned before, the inverse function has a restricted domain. So let's go over the rules that you need to know regarding inverse functions and their restrictions. So whenever you're dealing with the inverse function, sine can only be in quadrants 1 and 4. It can't be in quadrant 2. And 150 is in quadrant 2. And that's why the inverse sine of a half doesn't give you 150. It gives you 30 because 30 is in quadrant 1. So inverse sine only works in 1 and 4. And you need to know the angles. And that it's between negative 90 and 90. So let's say if you want to find the inverse sine of negative a half. Well, we know that sine is negative in quadrant 4. And we know that sine 330 is negative a half. However, the inverse sine does not equal 330. Even though 330 is in quadrant 4, 330 is not between negative 90 and 90. Inverse sine is limited between negative 90 and 90. Now, sine of negative 30 is also negative a half. Negative 30 and 330 are coterminal angles. They're both right here. You can go 330 in this direction, or you can go negative 30 in this direction. So they're coterminal angles. They differ by 360. So they're both in quadrant 4. However, negative 30 is in the range of negative 90 to 90. That's the range of the inverse sine function. So negative 30 works. So the inverse sine of negative a half is indeed negative 30 and not 330. Even though both are in the right quadrant, negative 30 is in the restricted domain of inverse sine, which is between negative 90 and 90. So make sure you're aware of that. The next trig function that we need to talk about is inverse cosine. Inverse cosine exists between quadrants 1 and 2. So the restricted domain for inverse cosine is from 0 to 180. And for inverse tangent, it's like inverse sine, it's quadrant 1 and 4. So none of them exist in quadrant 3 for the inverse functions. So sine and tangent is from negative 90 to 90, quadrants 1 and 4. Inverse cosine is quadrant 1 and 2 from 0 to 180. So, knowing that, let's evaluate inverse cosine of 1/2. Feel free to pause the video and figure out what inverse cosine of a half is. So we know that cosine of 60 is 1/2, and also cosine of 300 is a half. Now 300 is in quadrant 4, and inverse cosine doesn't exist in quadrant 4, so we can't use the 300. So it's 60. So inverse cosine of a half is 60. Now what about inverse cosine of negative root 3 over 2? So cosine of, if you use the unit circle and you look at the x values, cosine of 150 is negative root 3 over 2. Cosine is negative in quadrants 2 and 3, and cosine 210 is also negative root 3 over 2. However, 210 is in quadrant 3, so we can't use that. So therefore, it's 150. 150 is in quadrant 2, and it's within the restricted domain. It's between 0 and 180. So now, what about inverse tangent of 1? So this has to be in quadrant 1 because it's positive. Inverse tan is positive in quadrant 1. And if you use the unit circle, it's 45. Now what about inverse tangent of negative root 3? What about that one? So tangent is negative in quadrants 2 and 4. Tan 120 is negative root 3. And tan of 300 is also negative root 3. And also tan negative 60 is also negative root 3. So inverse tan is negative in quadrant 4. We can't use 120. Now 300 and negative 60 is in quadrant 4. But we can't use 300 because it's outside of the restricted domain. It has to be between negative 90 and 90. So negative 60 fits the requirements. And so that's the answer. So whenever you're dealing with inverse sine and inverse tangent in quadrant 4, the angle is going to be between negative 90 to 0. It's not going to be between 270 and 360. Make sure you do not pick that answer. So that is it for this video. We've covered a lot of trig, and hopefully you found it to be educational. So thanks for watching, and have a great day.